Cryptography history begins with Caesar Cipher. Suppose that the message I would like to encrypt is attack tonight. I need to apply some pre-processing tasks before encryption. Firstly, I will discard blank characters because it can cause some tricks for attackers. Run this block and message is equal to message dot replace and replace blank characters. Secondly, all letters will be in lowercase. Message is equal to message dot lower, and this is the final form of my plain text. These blocks from 2 to 4 handles pre-processing tasks. Now it's time for encryption. Now I will iterate over the letters of the plain text, and that's why I'm going to create a function letters of plain text, and it expects message as input. Initialize a list for letters for I in range from 0 to length of the message, and get the I indexed message. Append a I indexed message to the letters list, and after the for loop return letters list. Here I'm gonna call letters of plain text and pass the message as input. Encryption logic will be applied to all of those letters. Now store those letters into the letters variable. Now I will iterate over letters for letter in letters. Let's see the current letter. Here I need a function which converts letters to numbers. Letter to number, the function name, and it expects letter as input. But before that, let's import string library and see string dot ASCII lowercase. This is my alphabet. I'm gonna use string dot ASCII lowercase dot index and letter. This value will be returned. Here let's apply letter to number function. A becomes 0 and T becomes 19. These are the index values of these letters. Now I need a K to apply encryption, and let's say it's 2. Here I will add K value. Let's see K added letters. Now I need to convert these new indexes to the letters again. I will create a new function number to letter, and it expects number as input, and it's going to return char int value of number plus 97. Here I will apply this new function, and as seen, this is the ciphertext. Let's store it in the ciphertext variable. It's a list, and here append to the ciphertext. Let's see the ciphertext value here. Now encryption is over and it's time to decryption. Iterate over the ciphertext, cipher in ciphertext, and let's print first. Convert these ciphertext letters to numbers again. I'm going to use letter to number function here. And here minus k value. Notice that sign is minus in decryption and sign is plus in encryption. Now I need to convert these indexes to the letters again, and I'm going to use number to letter function here. And this is my restored plain text. I decrypt the ciphertext and restore this message attack tonight. Let's store this in the restored plain text variable, and it's the list, and here append these values to the restored plain text. Let's see the restored plain text here. You can change the k value here. For example, it will be 5, and I'm going to restart the kernel and run the old program again. As seen, ciphertext is changed, but restored plain text still same. To sum up, Alice wants to send the attack tonight message to Bob, and she encrypts the message and sends this ciphertext to Bob. When Bob receives this ciphertext, it decrypts it and retrieves this plain message. Notice that both encryption and decryption tasks require k values. This means that Alice and Bob, they both know the k value. What about Carol? She wants to attack this ciphertext and she doesn't know the k value. Attacker site. We always suppose that Carol knows encryption method, which is Caesar Cipher here. She only doesn't know the k value. Notice that English alphabet is consisting of 26 letters. That's why Carol will build a for loop for I, for actually k, in range of from 0 to 26. Also, she will iterate over the ciphertext here for cipher in ciphertext. Similar to this block, Carol will use same logic, and let's initialize the restored plain text here for the second for loop. And after the second for loop, let's print the restored plain text. She runs this block and retrieves these values. Let's focus on the this line. It's the plain text. Even though Carol doesn't know the k value, she tries all possible k candidates and she can find this plain text value, and it's very easy task for Carol. By the way, some illegal characters exist in this table. We can handle this actually. I will handle this calculation in a custom line, and I will store it in a new variable restored code. Here I will check its value is less than 0. If this condition is satisfied, then I'm going to append the number of letters in my alphabet. Also, it can be greater than 25. In this case, I'm going to calculate the module value. Let's run this block again, and it seems it's valid now. We should apply this logic for both encryption and decryption. Code is equal to this value, and here I'm gonna check it's less than 0. If this condition is satisfied, then I'm going to add the number of letters in my alphabet. Otherwise, I'm gonna check it's greater than 25. If this condition is satisfied, then I'm gonna calculate the mod value. Similarly, I apply this logic for encryption block. Now I'm gonna run all the notebook again, and it seems it's restored successfully, and it can be attacked successfully again. To sum up, Carol can break the Caesar Cipher in maximum 26 steps, as seen. This means that key space of Caesar Cipher is 26. So we have mentioned Caesar Cipher in this video. Thank you for watching and attending, and see you next time.